All right, next up we've got vector A having magnitude of 4, vector B has a magnitude of 3. Pick the directions and add A and B so the resultant has a magnitude of 7 for the first one. That's easy, right? We should have vector A, 1, 2, 3, 4. There's vector A, B, 1, 2, 3. If they're in the same direction, then the total resultant is just going to be 7. So this would be the resultant. Next one, vector B has magnitude 3, A is 4, magnitude of 1. Well, that would mean we're starting out with vector A, 1, 2, 3, 4. Vector A. Vector B, which I will use yellow, 1, 2, 3. And the resultant vector, what's left over, I'll use green for this one, is just a magnitude of positive 1. Or magnitude 1, because magnitude and absolute value is the same thing, right? Next, 4, 3, magnitude of 5. If you know your geometry, you know 3, 4, and can be added together like this. We have 1, 2, 3, 4 for vector A. Vector B, 1, 2, 3. Then vector C, or the resultant, is just going to be from the ending to the start. It's a 3, 4, 5 triangle. 3, 4, 5 right triangle. There's our right angle right here. And there we go. What's up next? Circles. All right. Let's do it. We have let vectors A equals 5 at 53.15 and B is negative 5 at negative 143. Find the components of each vector and draw each vector on the grids below. All right, let's first draw the vector. A is 5 at 53.15, so it's not going to be 60, so it's going to be 1, 2, 3, 4, 5. Just counting those concentric circles to give me my units as I go out. 5 gets me to the outermost ring. And then vector B, magnitude 5 at negative 143 degrees. All the way to the outer circle, somewhere approximately in there. Now to get our components, remember we have to do magnitude cosine theta for the x component. Magnitude cosine theta will give me a x component. Magnitude sine theta will give me my y component. For a, y, or bx or by. It's going to be the same basic formula, just different numbers, obviously. Let me pause this and do my calculations, and I'll be right back with the answers. All right, so when we do 5 times cosine 5313, we get 3. When we do 5 sine 53, we get 4. For vector B, we have a negative x, so don't forget we're adding 180 degrees to whatever our answer was. So we get components of negative 4, negative 3. We're finding the resultant of A and 2B by adding the components and using the grid below. Let's go ahead and hold off on the graph until we figure out what the resultant is. All right, so we're looking for the x and y components first, and then we're going to add up the twice the x components and twice the y components for B to get our resultant vector. So let's go ahead and find our x components. We do the magnitude times cosine the angle to get the x component, magnitude times sine of the angle to get the y components. I've done that already, where we get 3 and 4, remember in the last problem. And then the next one is twice the x component, which was -4, and twice that is -8, and then -6. We have a negative in the x component, so we have to remember the angle that we're going to get is going to be 180 degrees off. Okay? Let's see what we got. So 2b is not magnitude 5, it's magnitude 10, right? So 5 plus 10 is... No, not 15. To find the resultant, remember we're adding up the x components and the y components. And they are perpendicular to each other, so we have to use the Pythagorean Theorem to get whatever the resultant is. And there's a Pythagorean Theorem as it relates to us. The x component squared plus the y component squared will give us, and the square root of all of that will give us our resultant vector. So the x's, we're going to add up the x's. -8 plus 3 is going to be -5. -6 plus 4 is going to give us -2. So we have -5 squared, which is 25, plus -2 squared, which is 4. So we have 29. Don't forget to take the square root of that, and that'll give us our resultant magnitude. And that resultant magnitude, when you plug it in, is going to be 5.4. 5.4. Now, for the angle, we can use the angle formula. Theta equals arctan y over x. So the y component is -2, and the x component is -5. I didn't mean to erase that. -2, and then -5. When you put that in, you're going to get 21.8. No, can't be 21.8. Remember, that is 180 degrees off. So the denominator is negative. Tan theta is going to give 180 degrees off of the right answer. Are we adding 180 to the 21.8, or are we subtracting? Well, if you're not sure, then draw it out. If we have a -5 and a -2 as our x and y components, we know it's going to be -1, 2, 3, 4, 5, and then 1, 2. So we know we're going to end up somewhere over here, which is somewhere between 150 and 165. So we need to subtract 180 degrees from this. And that's going to give us -158 degrees.